Okay, here's warm-up 7.4. We're going to sketch this and include intercepts and asymptotes. So first thing I'd be looking for is to see if I can do any factoring, which I can't. Neither of those are factorable. And then if I could do any reducing. I often will see people cancel the ones here, but you can't do that because they're both part of those binomials, and I can't factor out, yeah, you can't just cross the ones out. Same with the x's. They're both attached to those other terms, so that's not going to work. Okay, so next up, let's start with the intercepts. I find the intercepts I do the same way I do on any equation. I'm going to be plugging in zeros. So x-intercept, I'll plug in 0 for y. And if I multiply both sides by x plus 1 times 0 is just going to be 0. So a shortcut here is just set the numerator equal to 0 to find the x-intercept. So subtract 1 from both sides and divide by 2. So negative 1/2 is my x-intercept. Okay, let's put that in there. There's negative 1/2. And then for the y-intercept, I'm going to be plugging in 0 for the x's. And all that's left is 1 in the numerator and denominator. So I've got a y-intercept of 1. Okay. All right, so I've got that so far. Let's put in some asymptotes now. So vertical asymptote is going to come from the undefined x values. So I'm thinking, what can't I plug in for x? Well, I can't plug in things for x that are going to give me a 0 denominator. So I can't have that whole denominator equal 0. So that means x can't equal negative 1. So x equals negative 1 is off limits. So let's put a vertical line there, because it's a vertical asymptote. These are all the x coordinates of negative 1, right? So that's an asymptote, okay? And then for a horizontal asymptote, what I'm going to do is use a little formula. I'm only going to use this when I call these balanced equations, where the numerator and denominator are the same degree. These are both first degree, right? Because 2x is the first and x is the first. And in that case, it's going to be, to get a horizontal line, I have y equals something. And I'm going to take the leading coefficient of the numerator over the leading coefficient of the denominator. Okay, so my leading coefficients here are 2 and 1, right? So this is going to be the y equals 2 over 1, which is just y equals 2. So that means I've got a horizontal asymptote like so. And those asymptotes are really going to help me to get an idea of what this is going to look like. So I should have a curve going like this. You could always plug in some more x's and find the y's that go with them, but I'm going to have the mirror image of that on the diagonal corner as well. So I should have a curve up here as well. And again, you could verify that by like plugging in -2 or -3 or -4 for x. Okay. All right, next problem. We've got, we're going to simplify here. So I'm dividing. So I am going to factor everything, and then I'm also going to rewrite this as multiplication by flipping the second fraction. Okay, but let's start with the numerator here. So I'm just going to set up some diamond problems, putting -2 up here, -8. Okay, looking for two numbers that multiply to -8 and add to -2. So let's see, 1 and an 8's no good, but I can do something with a 2 and a 4, like so. Okay, and then let's look at the bottom here. I'll do a diamond problem here as well. Okay, I can do something with a 3 and a 5. If the 5 is negative, that'll work out. Okay, so this first fraction then, on top, I'm going to get x plus 2 times x minus 4. On bottom, I would have x plus 3 times x minus 5. Okay? Then I'm going to factor this, but I'm also going to flip this at the same time so I don't have to rewrite it too many times. So both in the numerator and denominator, I'm going to have common terms, right? So in the top, I could factor out a 2 and also an x. So that would leave me with this, right? Now that's going to wind up on bottom when I rewrite this as multiplication. So let's put that down there. Okay, and then the denominator here, I can also factor out 2x, and that would leave me with this. So again, that's going to wind up on top, when it's written as multiplication. Okay. Now with multiplication, you don't need a common denominator. You just multiply straight across in the numerator and in the denominator. So what I like to do is just make this one big fraction like so. Okay, and now I'm going to start looking for anything I can cancel out. So I see 2x, 2x, those are gone. Okay, and then x minus 5 over x minus 5 would equal 1, so I can cancel those. The x minus 4's cancel as well. So I'm going to get x plus 2 over x plus 3. That's all that's left. Now, one other thing we should really put, this isn't quite equal to this, this original expression, because there are certain undefined x values. Okay, so for example, in I can't plug in. I can't. If you look to before we canceled here, if you were to plug in -3 or +5 into that into this trinomial, it would give you a 0 denominator. Okay, so I'm looking back at anything that's been in the denominator at any point. So x can't equal, these are equal with the understanding that x cannot equal -3 or +5, because that would give me a 0 denominator. Let's look at this denominator. The things I can't plug in here would be 0 and +5. Well, I've already listed 5, but I haven't listed 0 yet. Okay, and then in order to solve this, I flip that second fraction, so 0 again wouldn't work, but +4 also wouldn't work. So these are all my undefined x values that would make those not, this simpler fraction not equal to the original expression. Okay, that's the end of the warm-up, and I'll see you next time.